Chemical equilibrium ke yona ke is when, that is dynamic equilibrium, is when the concentration of the products and the concentration of reactants is constant. If the concentration is constant, so sithi lapho sireache i-dynamic equilibrium. Now let's make an example of hydrogen. The hydrogen gas which reacts with maybe with a nitrogen, with a nitrogen gas, that is N, with a nitrogen gas. Then we get the ammonia. Then we get the ammonia, that is ammonia. So sibe ammonia pa. Now let's balance the equation. We can put 3 here, then we can put 2 here. Even this one is a gas. Now we have constant hydrogen, we have ammonia, nitrogen, sibe ammonia. Now let's say silapho concentration, because the definition yokuqala ithetha ngantoni, the concentration. So silapho concentration, let's say this one is hydrogen. So sinale hydrogen gas, then sibe nale nitrogen gas, sibe nale nitrogen gas, then sibe ammonia, sibe ammonia, that is NH3. So now that the concentration here does not change up to this time, let's say this one is T1, up to this time the concentration does not change there, therefore this is the equilibrium. Now the following definition of chemical equilibrium, the rate of forward reaction equals the rate of reverse reaction. The rate of forward reaction equals the rate of reverse reaction. That is the dynamic equilibrium. Now let's say we have this one, that is the reverse reaction. Then sibe nalena a reaction, this one, that is forward reaction. So when zilingana pha sireache i-dynamic equilibrium, sikwi-equilibrium. In other words, xa zilingana kanjeya sikwi-equilibrium. So sibe ne-factors that will affect the equilibrium. The equilibrium is the flat area here. So nalapha the equilibrium le ndawo i-flat. Sibe ne-factors ke ngoku ezi-affecta i-equilibrium. So we'll start with concentration only. If you increase the concentration, the equilibrium will be disturbed by Le Chatelier's principle. The equilibrium will be disturbed. Now if we talk about the concentration as a factor, once you change concentration, the equilibrium will be disturbed. Concentration. Once you change temperature, the equilibrium will be disturbed. So let's say you increase the concentration of one of two. Increase the what? The concentration, for example, of hydrogen gas. Xa ndicacisa ke ngoku ndizosiso ndithi okay, kweli cala ne-hydrogen ndiphinde ndibe ne-nitrogen and nitrogen kweli cala, then that is nitrogen, then kweli cala ndibe ne-ammonia kweli cala, that is product yethu. Phaa kusiso, if you increase kweli cala, eli cala lizo drop, eli linyuke. So eli cala xa linyuke li-favored, which means the reverse reaction is favored. If unyuke eli cala le product linyuke leze phezulu, forward reaction is favored. So xa sizoba ke ngoku apha kwi-concentration siqala nge-disturbance. I-disturbance yethu ithi si-increase i-concentration ka-hydrogen, which means concentration is disturbed. Concentration is disturbed phaa concentration ka-hydrogen. Then what will happen to the equilibrium position? If you add more hydrogen gas here, when you add more hydrogen gas, this side will go down. Therefore, this side will go upwards. Meaning that if we increase the concentration of hydrogen, forward reaction is favored. Forward reaction is favored. When forward reaction is favored, yintoni ezonyuka? I-ammonia, the concentration of ammonia, i-concentration ye-ammonia izo-increase ekugqibeleni, kuzo-increase yona ekugqibeleni. Njengoba beqala kwa-increase i-hydrogen, ibi-increase kuba idisturbiwe, but forward reaction is favored, therefore the ammonia will go up ekugqibeleni. Xa i-ammonia inyuka ithethe ukuthi i-hydrogen ne-nitrogen zona ziyehla ekugqibeleni. So let's draw igraph yethu. So i-ammonia iyenyuka because forward reaction is favored. Ammonia is increasing concentration ye-ammonia. Reach another equilibrium, but concentration ye-reactants is decreasing. Reach another equilibrium, is decreasing. Reach another equilibrium. So sibe sigqibile ke ngule concentration. What about the rate? When you increase the concentration of one, the rate of reaction increases. So if we increase our concentration, the rate of reaction increases. But between the two rates, khona ezo increase more than enye. The one that is favored will increase more than enye. So we said forward reaction is favored, which means forward reaction will increase more than reverse reaction. Go forward wethu besithe ngulo forward, then reverse wethu ibe ngulo reverse wethu. That is our reverse. So forward reaction will be favored more than reverse reaction. So forward reaction nago increase more. Forward reaction is increasing more than what? The reverse reaction. Nansi ya. Then ijike igraph yethu. Then that one izokwehla to reach equilibrium again, izokwehla ihlangabeza le siphinde zithini zilingane, siphinde sithi siye safumana equilibrium again. Okay, now let's check factor number 2. What will happen if we decrease one of two? Let's say now we decrease one of two. Let's decrease. Okay, siya decrease ngoku. Enye yazo kuzokwenzeka ntoni kwi-rate na concentration? Decrease concentration of, let's say, nitrogen in this time. Nitrogen. Let's say the concentration of nitrogen is increased. That is nitrogen. Now the nitrogen is increased. What will happen? So sizozoba usiso wethu. We have the ammonia in this side. Then in this side we have nitrogen and hydrogen gas. So we decrease the nitrogen. As it decrease nitrogen, eliqala izoba lula in weight. Let's start with the disturbance. the nitrogen is decreased, which means the nitrogen is disturbed, decreased. Then if we decrease the nitrogen, what will happen here? Xa sidecrease kweli cala lizothini lilonke, eli cala lilonke lizo increase. So eli cala lilonke liya increase, so na liyalinyuka eli cala lilonke. Then eli cala kwenzekani kuyo, liyasinka na lisehla. What does that mean? Reverse reaction is favored because uyenyuka. So xa ungu-reverse reaction of favored ithetha ukuthi concentration reverse reaction is favored. So when reverse reaction is favored, the concentration of a reactants, let's say the concentration of a product, that is ammonia, the concentration of ammonia, NH3, decreases because reverse reaction is favored. Xa concentration ka ammonia decrease, ka hydrogen yona iyathini? Concentration of hydrogen increases to reach a new equilibrium. Xa eka hydrogen increase, eka hydrogen kwenzeka ntoni kuyo? The concentration of nitrogen increases, which means i-reactants ziyathini? Ziya increase when we decrease one of the reactants. I-reactants ziyathini? Ziya increase ekugqibeleni. Sibhala i-disturbance kuqala, nansi i-disturbance. Then siyojonga uba which reaction is favored. Then reverse reaction is favored. So when the reverse reaction is favored, the concentration of ammonia decreases. Where is the ammonia? Now let's draw the ammonia. I-ammonia yona ekugqibeleni izo-decrease because it is not favored. Then what about the nitrogen? I-nitrogen ibidisturbiwe but izonyuka to reinstate the new equilibrium. Then what about the hydrogen? Hydrogen nayo is favored, therefore izothini? Izonyuka. That is concentration, factor layer concentration. What about the rate? When we decrease concentration, noba yiphi, let's say hydrogen, once you decrease the concentration, the rate decreases, which means both forward and reverse reaction decreases. Both forward and reverse reaction decreases. Then which one will be favored more than enye? The one that is favored more than enye izoshiyeka phezulu. The one that is not favored izokwehla kakhulu. So we said reverse reaction is favored. So xa u-reverse reaction favored, which means u-forward reaction yena uzokwehla kakhulu. U-reverse reaction uzokwehla kancinci, ajike akhweze abe constant. Then the reverse reaction, the forward reaction that is not favored, yihle kakhulu, isogqiba iphinde ithini? Inyuke. Siyirishe equilibrium again. Then what if we increase the concentration again? When we increase concentration of what? If we increase the concentration maybe of a product, let's say you increase the concentration of ammonia, this side will be heavy, which means so therefore reverse reaction is favored. If we increase the concentration of nitrogen, eli cala lizoba nzima, lizokwehla, therefore forward reaction is favored. When forward reaction is favored, apha kwi-rate forward reaction uzonyuka kakhulu. Xa sithi forward reaction is favored uzonyuka kakhulu. Then reverse reaction is not favored uzonyuka kancinci because ithe increase. Xa se increase zinyuka zonke but enyuka kakhulu enyuka kancinci. So linyuka kancinci jike, then linyuka kakhulu, ithi senyuka kakhulu njalo inyuke ijike ibuye. Sirishe equilibrium again. So ihamba kanjalo ke ngoku. Let's check one question then sizodlulela kwenye ifactor. So sijonge umzekelo ke ngoku. Umzekelo wethu naku. Where is this example? Let me check this example. Where is it? The example there. So naku ke ngumzekelo. We have here, we have le reaction yethu, this one, that is A2 B bengu A2 no B2 i-product. So sineza products zoyi-2. Then igraph yethu here ye-rate. So igraph yethu ye-rate. So njengoba iye-rate le graph yethu ithethi ukuthi sojonga nje uba which reaction is favored, is it forward or reverse only, because we have only two graphs. So igraph eqale yehle kwi-rate ngu-forward reaction, this is forward, and this one is a reverse reaction. So sino forward no reverse. Then if singajonga kule ndawo, the rates are equal here. Rate of forward reaction and reverse reaction are equal. If we look here, the rates are equal here, which means that is the dynamic equilibrium. Even this one, the rates are equal there, which is the dynamic equilibrium. The rates here are equal, which is the dynamic equilibrium. Then if you can look here, for example, up 120, when the time is 120, that is here, the equilibrium is disturbed, which means asekho pha flat ngoku. Then zanyuka zoyi-2, which means increase in concentration of what? Between the two. So jonga uba yi-concentration yantoni enyukileyo pha. Then uba singajonga apha, the reverse reaction is favored more than forward reaction. So reverse reaction unyuke kakhulu, which means is favored more than reverse reaction, which means kweli xesha ke ngoku u-forward ubani reverse reaction is favored more than what? More than the forward reaction. So reverse reaction is favored, in other words, meaning that ku-increaswe i-concentration yantoni yezi zoyi-2. Maybe ku-increaswe i-concentration yale. What so increase i-concentration yale? Eli cala la heavy lehla. So reverse reaction is favored. Now let's look at T80 18. Apha ku-180 seconds, reverse reaction decreased more than forward reaction, which means forward reaction here is favored. Forward reaction is favored. Forward reaction is forward reaction is favored here. Why? Because forward ungehla kuno reverse. U-reverse wehle kakhulu, which means akekho favored. Forward ungehla, forward nako ungehla kuno reverse kule ndawo. Then sibe no time, which is 240. Then ku time 240 seconds zinyuke zoyi-2 equally. So xa zinyuke zoyi-2 equally, i-factor, it's not a temperature, it's not the concentration, it's not the pressure, because zinyuke zoyi-2. It's not the concentration, it's not the pressure, it's not the temperature. Ingayintoni that is not a factor affecta i-chemical equilibrium? Ungayi-addition of a catalyst. So ingayi-addition of a catalyst here. So i-catalyst li-addwe pha. Xa kungeyiyo i-catalyst ingayintoni? For example, besingathi surface area, but there is no solid species there. So apha kule ndawo icacile ifactor i-1, i-catalyst e-addweyo here. So apha forward reaction is, so forward reaction here Oh, that is reverse. The bold line is reverse. Reverse direction is favored more than forward. Reverse direction is favored, which means we increase i-concentration yenye yezi products. Then apha kwenzeke ntoni? Forward reaction is favored because ungentla kuno-reverse. Engentla is favored. So ithethe ukuthi xa injalo kwenzeke ntoni ke ngoku? When the forward direction is favored, which means ku-increase i-concentration yaleyo umzekelo, then eli cala lanzima forward direction is favored. Then apha ku-edwe i-catalyst. Why i-catalyst? Ziigesi zonke, which means ku-edwe i-catalyst. If bekwi-solid ibingayi-catalyst or surface area, so ihamba kanjalo, that is the concentration. The next one will be the temperature. The next one will be the